Hi everybody, it's Mrs. Mancuso, and today we are going to be doing the June 2018 exam. We're on part B1. This is video 2 of 4 going through the exam. So we'll go through question by question. The first one here is showing us a bright line spectrum. And the question says, which elements are present in the mixture? So here's the mixture. Here's the possibilities, A, D, X, and Z. So these two lines look like they're coming from element X, so X is in there. This line isn't shown, so Z is not in the mixture. This line looks like it's coming from element A, and then I'm just going to zoom over and look and see what's in D. D has these two lines, and they are not in the mixture, so D is not there. So I want A and X. All right. Each line in the spectra represents the energy. Okay. Here's my nucleus. Here's my energy levels. Here's an electron, and it is in the ground state right now. It could get excited and go out here to an outer energy level, and that's where it would have higher energy, but it doesn't stay there. So as the electron falls back to ground state, it releases energy. And when it releases that energy, it releases it as wavelengths of color. So you do not get the color when you absorb. You get the energy when you release an electron. And it is not from low to high, it's from high to low. This is a really common question on part 2, so that's a good one. All right, next one. The table below shows protons, neutrons, and electrons in 4 ions. So that means it's going to have a charge to it. Which ion has a charge of -2? So I'm going to go ahead and label this column plus because protons are positive and neutrons have no charge. So I'm just going to cross that out. And then electrons are negative. So I want to find one where there's 2 more negatives than positives. So A does. A has 2 more negatives than positives, so A is a -2. What is the approximate mass of an atom that contains 26 protons, 26 electrons, and 19 neutrons? So I'm going to cross the electrons off right away because electrons don't weigh anything. And I'm going to add together 26 and 19, and I'm going to get 45. So that would be the mass. So the mass is equal to the protons plus the neutrons. Which electron configuration represents a potassium atom in the excited state? So let's go look up what it is in the ground state. So we go here and potassium. So potassium is K. Whoa, sorry. Okay, back to this. Oh boy, sorry about that. All right, so now I have potassium and it's 2881. 2881. I guess I'll go off that page. Oops. (2881) is what potassium has. So that adds up to 19. So first of all, I'm going to cross off 3 because that's the ground state. I want to keep 19. So this doesn't add up to 19 and this doesn't add up to 19. In this one, one electron has moved from the 3rd energy level to the 4th. And so that is what excited means. It has moved out to a higher energy level. What's the total number of neutrons in an atom of K42? So K42, and we just said it was element 19. So if you want to know the neutrons, you simply set it up like this and go minus. So 42 minus 19. Whoops, sorry, I did something wrong. 42 minus 19. I don't know why I'm not even just doing this in my head. 23. All right, next one. Given a reaction representing or given the equation representing a reaction, what's the number of moles of carbon that must completely react to make 2 moles of C2H6? So think of it as like this is my recipe, and instead of making 1, I want to make 2. So that means I should double everything. So instead of 3, I should have 6, and instead of 2, I should have 4. So how many moles of carbon? I should have 4. What type of chemical reaction is represented by the equation? So I have an element plus a compound, and I end up with a different compound plus an element. So I have one switch, so that's called single replacement. If I had a compound with a compound, that would be double replacement. All right, the table below lists properties of elements at room temperature. Based on the table, which statement describes how two of these elements can be differentiated from each other? All right, gold can be differentiated from tungsten based on density. All right, gold and tungsten have the same density, so no. Gold can be differentiated from sodium based on malleability. No, they both have the same, so no. Sodium can be differentiated from tungsten based on conductivity. Sodium, tungsten, both good. Nope. Sodium can be differentiated from iodine based on malleability. Yes, here we have two things that are different. Which particle diagram is a mixture? All right, this is definitely a compound, so those are the same molecules. This is also a compound. This one's a mixture because you have two different things, and this is an element, so I want choice 3. An atom of which element reacts with an atom of hydrogen to form a bond with the greatest degree of polarity? So hydrogen and what other thing? Now, if I want the greatest degree of polarity, I have to look up the electronegativity difference, and I want it to be the greatest. So carbon, fluorine, nitrogen, and oxygen. All right. Here we go. Hydrogen is a 2.2. The difference between that and carbon is a 0.4. Nitrogen is a 0.8. I can't think if oxygen was on there. Maybe it was oxygen. But fluorine was on there, and that's a 4.0. So that's going to be the greatest difference. That'll give me the most polarity. So fluorine. What is the concentration of an aqueous solution that contains 1.5 moles of NaCl in 500 milliliters of solution? Okay, so first let's look for our formula. So here's table T. Molarity is equal to moles of solute per liters of solution. All right, so we go back down here. I have 1.5 moles, and then this is milliliters. So to convert it, I have to go 1, 2, 3 decimal places. So that's in 0.5 liters of solution. So 1.5 divided by 0.5 is going to give me 3. So it's a 3 molar solution. All right, which two gas samples contain the same number of molecules? So if I want the same number of molecules, I have to have the same temperature, the same pressure, and the same volume. So 602 and 5. I don't see anything else that has a 1, so it's going to cross those out. 301 and 10, 301 and 10. So 2 and 4 have the same conditions. Based on table I, what's the delta H value for the production of 1 mole of NO2 from its elements? So delta H for 1 mole of NO2. Okay, NO2 from its elements, nitrogen and oxygen. All right, I gotta go look up this again because there's 2 reactions that have it. Okay, sorry, it takes a while to flip back and forth. So here's NO2 gas. I just had to make sure I was looking for the right one. And the normal thing makes 2 of it. So I want to take 66.4 and I want to divide it in half. So that would give me 33.2. So that's how much I would make, 33.2. Go back to my question. Thanks for being so patient. This is definitely a lot of work. Okay, which equation represents an addition reaction? So if you have an addition reaction, first of all, I can cross this one right off and this one right off because I know it's an organic reaction. I know I need to start off with an alkene. So an alkene has CnH2n. So this one is an alkane, so that can't be my choice. And then the other thing that's cool about it, see, this first one was a substitution. I just have one product. If you break the double bond, you can add the chlorine in and you will make one product. So that's definitely addition. Given the balanced equation representing a reaction, in this reaction, each Ni atom, all right, we have to figure out what it gains or loses. So it starts off at 0, and over here it's a +2. So to go from 0 to a +2, it has lost 2 electrons. Lose 2 negatives and you will be positive. Which equation represents a reduction half reaction? So reduction is gaining. So I need to gain electrons, so it can't be 1 and 3. And then I need to make sure that it balances out. So if I have iron at 0 and I add 3 negatives, I should come out with negatives. If I have 3 positives and I add 3 negatives, I should come out at 0. So that one is balanced. Given the equation representing a reaction, during this reaction, electrons are transferred from. So they're always transferred from what's being oxidized to what's being reduced. And the oxidation number goes up if you're oxidized, and the oxidation number goes down if you're reduced. So this is a 0, this is a +1, this is a +2, and this is a 0. So the one that is going up is Cu, and the one that is going down is Ag +1. So they're going from Cu to Ag +1. Which metal reacts spontaneously with Sr +2 ions? If it reacts spontaneously, it's got to be higher than the ions. So which one's higher than Sr? Ca, Co, Cs, Cu. So let's go find table J. Here's table J. And here's Sr. So what's higher than it? Cs. To be spontaneous, you need the metal to be higher than, because it's going to be oxidized, so it's going to be higher than what's being reduced. All right, and the water molecule acts as a base because it. All right, there's 2 ways you could do this. If something is a base, it's either because it is donating OH or accepting H+. And in this situation, water is being the base, so water does not donate H or OHs or anything. You have to look at these. Look at how it appears before the arrow and how it appears after. So this one loses an H to the water and forms H3O. So wherever it goes from is your acid, wherever it goes to is your base. So the water is a base because it's accepting the H+. All right, thanks for joining me for this video, and join the next one for video 3 of the June 2018 exam.